Introduction to Docker and Containerization. Docker is an open-source platform that enables developers to automate the deployment of applications within lightweight, portable containers. These containers encapsulate an application and its dependencies, ensuring consistency across different environments. Using Docker for containerized development environments simplifies the setup and management of applications, enhancing productivity and collaboration. Installing Docker on your system. To get started with Docker, the first step is to install it on your operating system. Docker is compatible with Windows, macOS, and various Linux distributions. Visit the official Docker website to download the installation package, and follow the instructions for your specific OS. After installation, verify that Docker is running by executing the command docker version in your terminal or command prompt. Creating your first Docker container. Once Docker is installed, you can create your first container. Begin by pulling a base image from Docker Hub, which is a repository of pre-built Docker images. For instance, you can run docker pull Python 3.9 to download the Python image. Next, create a new container using the command docker run it Python 3.9 to start an interactive terminal session within the container. Setting up your development environment. Inside the Docker container, you can set up your development environment as you would on your local machine. Install necessary libraries and tools using package managers like pip for Python or npm for Node.js. To keep your setup consistent, consider creating a Docker file that defines the environment configuration, including the base image, dependencies, and any additional setup commands. Using Docker Compose for multi-container applications. For more complex applications that require multiple services, Docker Compose is an invaluable tool. Create a Docker Compose.yml file to define the services, networks, and volumes needed for your application. This file allows you to start all services with a single command, Docker Compose up, streamlining the process of managing multiple containers. Persisting data with Docker volumes. By default, data created within a container is lost when the container is removed. To persist data, use Docker volumes. Volumes are stored outside the container's file system, allowing data to remain intact even if the container is deleted. Create a volume with the command docker volume create my_volume, and use it in your docker run command or docker compose.yml file. Debugging and managing containers. Managing and debugging containers is essential for effective development. Use commands like docker ps to list running containers, docker logs, container_id, to view logs, and docker execute, container_id, bash to access a running container's terminal. Understanding these commands will help you troubleshoot issues and streamline your development workflow. Conclusion: benefits of using Docker for development. Using Docker for containerized development environments offers numerous benefits, including consistency across various platforms, simplified dependency management, and easy collaboration among team members. By leveraging Docker, developers can create efficient and reproducible environments that enhance productivity and reduce the challenges associated with traditional development setups. Embracing containerization is a key step in modern software development practices.